Example 3. A cutout that creates an open top box is shown. How large should the squares be cut in the corners to make a box that holds as much as possible? So what I mean by that is we are going to take a perfectly rectangular piece of paper or sheet metal or whatever, and we're going to cut the corners out. We're going to cut these pieces out so that way when we fold these ends up, it's going to make a box. So to visualize that, I went ahead and rendered it in 3D. So as we see here, we cut it out and we take these orange pieces and we're going to fold them up to make a box like this. Okay. So what we're doing now is we're going to model the problem with this diagram. So what I'm going to do is I'm going to choose to let these be x, because this is how much we're going to cut into the box. We don't know how much we're going to cut into the box, but we're going to cut this much. I'm also going to tell you that this whole piece right here is 25 inches. And I'm going to tell you that this whole piece is 20 inches. So that means that the distance from here to here is 25 minus 2x. That's because we have an x here and an x here. So the whole thing is 25 from here to here. From here to here is 25 minus this piece and this piece. And now let's talk about this distance right here. And this is going to be 20 minus 2x. Because this whole thing from the top to bottom is 20. And then this is x and this is x, so it's 20 minus 2x. So let's talk about modeling this problem. So what do we want to find? What we want to find is volume, which means we need an equation for volume. Well, we know volume of a box is length times width times height. Well, already this is a problem because we have 3 variables. Ideally, we only want 1, which means we need to figure out a way to make it so we only have 1 variable. Well, we know that we called the height of the box x. So let's talk about the length. The length is this piece right here. So the whole length is 25 minus 2x, because this is not the length of the box, just this purple piece in, because this whole section right here is going to be folded up. And then the width is 20 minus 2x. So what we're going to do now is we're going to substitute it in our volume formula, and we get 25 minus 2x times 20 minus 2x times x. So our volume in terms of x is this polynomial right here. So first let's talk about domain. Domain of the function is when you let the volume equal 0. So we're going to let our original function equal 0. So you set each piece equal to 0 using the 0 product property. And we're going to go ahead and solve those. So you get x is equal to 17.5, x is equal to 10, and x is equal to 0. So this means that the domain is between 0 and here's the catch. Is it 17.5 or 10? Remember, these x values have to work to satisfy every piece of this. So if you were to plug 17.5 into here, it'd be okay. If you plug 17.5 into here, it would be okay. But if you plug 17.5 into the middle one, you're going to end up getting a negative. So that doesn't work. So that's why this value doesn't work. So our domain only goes to 10. just to visualize what's going on in this problem, I want us to be able to see exactly how the box changes. So what I'm going to do is I'm going to change the amount of the corners that I'm going to cut out, and you'll see the pieces of the corners when I animate this. So this distance right here, this is the corner that I'm cutting. And as you can see, as I make this more and more, the length and the width of the purple piece, which is the base of the box, gets smaller and smaller. What I mean by that, if we focus in over here, you can see the base, as the height of it gets smaller, the base is larger, and as the height gets larger, the base becomes smaller. So in this middle graph, I have represented the volume as the height changes. So here it's very plain to see where the maximum is for the volume. It's about right here. And this value happens when the height, or the amount that we're cutting out, is about 3.5 to 3.8 inches. So that should be our answer, somewhere in there. So let's go back and let's solve it algebraically. So we need to determine our maxes and our mins. So in order to do this, we have our volume function, which is x times 25 minus 2x times 20 minus 2x. And you can take the derivative right away here and just use the product rule 3 times. That's up to you. I'm going to choose instead to just distribute. And you get 500 minus 40x minus 50x plus 4x squared. So you get the volume is equal to 500x minus 90x squared plus 4x cubed. Now what we need to do is go ahead and take the derivative of that, and you get 500 minus 180x plus 12x squared. We're going to go ahead and simplify that and set it equal to 0. I can factor out a 4, and you get 3x squared minus 45x plus 125. So to solve this, we need to use the quadratic formula. So I hope we all remember the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have x equals 45 plus or minus 45 squared minus 4 times 3 times 125, all divided by 2 times 3. So when you plug that in your calculator, you'll get x is about 3.68 and 11.32. That makes sense. Those two x values, the quadratic equation typically gives us one or two values. But what we need to do is we need to check our domain. Do both these values work? Well, 3.68 does because it's between 0 and 10. 11.32 does not because it's larger than 10. So this is not in the domain. So now we get that this is our x value. Ding, ding, ding. This is our winner. So x is equal to the height So h then is equal to 3.68. L is equal to 25 minus 2x, which is 25 minus 2 times 3.68, which is 17.64. And the width is 20 minus 2x, which is 20 minus 2 times 3.68, which comes out to 16.32. So that gives us our three dimensions, but remember we want to find the maximum volume. So the volume of 3.68, remember volume is length times width times height, so this is 3.68, 17.64, 16.32. which ends up being 820.5 inches squared. So inches squared. Which means that we're done. And here's how we write our answer. So for the summary, we have the maximum volume of the box is 820.5 inches squared when you cut 3.68 inches from each corner. And here is your answer. You must answer your questions in a summary. Unless it's a multiple choice, then you don't have to. So that's how you optimize volume of box.